Assalamu alaikum, welcome back to EE204. So in this experiment 7, we're going to talk about two important devices, function generator and oscilloscope. So before actually talking about those devices, let's go back and discuss what we've done so far at this lab. So all of our experiments were about a direct current. So we have a DC circuit. So a DC circuit is a circuit that has a DC source. An example of DC sources is actually a battery. So that's the general structure of the circuit. This is R1, R2, and you can have as many resistors as you want. So if we want to plot, for example, the current versus time, or the voltage versus time. So we see here, if the x-axis is the time axis, the y-axis is the voltage axis, and let's say that this voltage source is 10 volts, for example. And we see here that if t equals to 0, at time equals to 0, we turn on the switch, then we see that the voltage is always constant. So it's going to be always 10 over up until t equals to infinity, where t equals to infinity is the time when we turn off the switch. Similarly, this is 10 volts. If we want to plot the current, it's going to have the same shape. However, if we want to actually have a current or a voltage that varies with respect to time, then we cannot use a battery for that. So we need to modify our analysis, we need to modify our sources, we need to modify our measurement technique. So remember, in order to create this circuit in the lab, we need a DC source and a digital multimeter. So the DC source will provide us with the voltage source. The digital multimeter will give us a way of measuring the voltage and the current at any point in the circuit. If we want to actually, instead of having a DC source, we want to have a voltage, and instead of a DC voltage, we want to have a voltage that actually varies with respect to time. For example, let's assume that for the same circuit here, we have, let me draw it again in a different color. So V1 is now function of time. So it's not going to be constant. It has a constant magnitude. And let's assume it's a cosine function. Cosine of 2 pi times f t plus theta. So V naught is the magnitude, sometimes called the amplitude. F is the frequency, which is the number of cycles per second. The unit is hertz, or 1/4 seconds. And theta is the phase offset. So if we are to plot this function versus time, we're going to end up with the following shape. Let's assume the offset is 0 here. So in this case, I will have something like this. So in order to having a voltage source or having a component, having a voltage source or current source that varies with respect to time is very important, especially if you want to transfer power from one point to another. For example, the transmission lines that carries power to your homes actually the voltage or the power over there is actually the voltage over there is actually an alternating voltage. It's not a constant. So if you have access to one of those power lines and you want to measure the voltage, you would see that the shape of the voltage will look a lot like this one. It will look a lot like this one. So now, if we have this circuit and we want to generate a voltage like this, so we cannot use a DC source. So we have to go to another device, or we have to use another device called function generator. So the function generator will generate a signal that varies with respect to time. So usually function generators generate three types of signals. One is sinusoids. The second one is square pulses. Or square signal. Third one is triangle. So in order to generate those signals, you have to have some an electronic device called oscillator. So the output of the oscillator will be one of those signals usually. Of course, after some modification and application to some filtering, and we won't deep dive into these into the electronics of those devices. But we see here that we have to have a different source for our circuit. We cannot actually use a DC source. And if you go to any function generator, you will see some components or some parameters that you need to play with. So the first one is actually the magnitude or the amplitude. So something similar to V naught here. Second one is the frequency. How many oscillations per second. Third one is the phase offset. Theta in the previous formula. Most likely we will not going to use this parameter. The fourth one is actually the offset, the DC offset. So this is not the general form. The general form is we have to add something called VDC. So if VDC is 0, means that the average of this sinusoid will be 0. If the DC component is not 0, it means that let's say like the VDC is positive, so this curve will go up. So this curve will go up by VDC. If it's negative, then this curve will go down by VDC. So the average will not be 0 at this point, the average will be VDC. So those are the four important parameters of a function generator. Now, if we want to actually measure the voltage at any point in the circuit, say at the voltage across this resistor, let me call it V2. Since the source is varying with respect to time, the source is, for example, here is sinusoid, then the voltage here must be sinusoid. However, in this case, the magnitude of the voltage will be different. It will not be exactly V0, it will be something, it will be a scaled version of that. So without going deep into this scaling factor, and if you want to measure, without going deep into this scaling factor, the magnitude or the voltage here can be measured using a device called oscilloscope. So the oscilloscope will take the output, will take the voltage. For example, the oscilloscope will have one channel that has both positive side and the negative side, and it will show in the screen the voltage, or let me make sure that this one is actually the same as that function. So the voltage here will be something like this. So V, the magnitude of that, let me call it Vx. Vx is a constant, or let me call it alpha, a scaling factor, multiplied by V0. So if we want to see the voltage, or if we want to view the voltage at any point in the circuit, then we have to use that device called the oscilloscope. So the oscilloscope is not going to generate any signal. It's actually a device that measures the signal in the time domain. So we want to use it to measure the time domain response of the signal or the voltage in this case. So what happens if the voltage is actually DC, if the source is DC, and you connect the oscilloscope to R2, then in this case, the voltage that's going to appear, it's going to be something like this, of course with different magnitude. So that covers the basic concepts of this circuit or this experiment. And the main motive for that is we want to supply our circuit with a voltage that's vary with respect to time. This is very important because a voltage that varies with respect to time is everywhere actually. So any time we want to transmit power from one point to another, we always use AC voltage, not a DC voltage. And as an interesting historical remark, there was a huge battle between Edison and Tesla. So Edison is the one who is in favor of DC voltage or DC direct current, while Tesla is the one who's in favor of AC current. So eventually the battle was won by Tesla, and if you want to read about it, you can look it up on Wikipedia. It's called War of the Currents.